this video I show you how to model fluid flow and heat transfer using ANSYS CFX. In our example, we have three-dimensional flow and we want to check an analysis, the airflow inside our domain, and we want to check the temperature distribution and velocity distribution in our domain. For this of the model, let's mount to ANSYS CFX. For this of the model, select CFX, right-click on Geometry and select New Design. Select XY Plan and also click on Z-axis, click on Sketching, select a rectangle. Okay. Now click on Dimension, select this line and also select this line. H1 is 10 and V2 is 2. Okay. Now click on Generate, click on Create and click on Revolve. Okay. For the geometry, we select sketch 1 and for the axis we use or select this line. Okay. Because we have symmetry in our domain, so we use only 90° for angle. Okay, now click on Generate. As you see here, our domain. Right click on Mesh and click on Edit. Now click on Mesh, click on Generate. Okay, it is our initial mesh. And now we want to create a banded layer for our domain. So right click on Mesh, click on Insert and also click Inflation. Okay, we select our domain. So for the geometry, okay, now click on Apply. For the boundary, we use this boundary. Okay, click on Apply. And for inflation option, we use fast layer thicknesses and we use 0.05. 0.005. Okay, now click on Generate. Okay, now we increase the number of mesh or the number of elements in our domain. So click on Mesh and click on Element Size and we use 0.08. Okay, now click on Generate. Now we create our boundary condition. So select this boundary and here we have inlet. Okay, here we have outlet. It is our heat flux. And finally, we have a symmetry boundary condition. So we select this boundary and also this boundary. So these are symmetry. Okay, so here, as you see, it is our inlet, outlet, and heat flux. And finally, we have symmetry boundary conditions. So now click on Mesh and click on Update. Now close the mesh. Now click on Setup and right click on Setup, click on Edit. Click on Analysis Type because we have a steady state simulation. So for this option, we select a steady state. Okay. Click on Default Domain. Okay, here because we have airflow inside our domain, so the material is air. Okay. And our morphology is continuous fluid. And another option is okay. So click on Fluid Models. Here we don't have isothermal condition, so we have a thermal energy equation. So we select thermal energy and click on Apply. Okay, and also click on OK. Here now we want to define our boundary condition. So right click on Default Domain, click on Insert, Boundary. Here we have Inlet boundary condition. For the location, we select Inlet, click on Boundary Details. For the airspeed we have or the velocity we have 1 meter per second, and for temperature we have 300 Kelvin. Okay, and now click on Apply. Okay, right click again and select Insert and select boundary condition. It is our outlet boundary condition, so we define outlet. So the location is outlet and click on boundary details, and here we have a 0 for relative pressure or gauge pressure. Okay, now click on Apply. Okay, now we define another boundary condition, and it is our symmetry boundary condition. Okay, we define or the change the boundary type to the symmetry, and we select our symmetry boundary condition, and now click on apply and click on OK. And here also we have heat flux boundary condition, so we select heat flux. Okay, the boundary type is wall. Okay, and click on boundary details. And for heat transfer we have heat flux and its value is 100 watt per square meters. So click on apply and now click on OK. Okay, our setup for the ANSYS CFX has been completed. So now we wanna run our model. So close the setup. Right click on solution, click on edit. Okay, here we use default option and select start run. Okay, the calculation has been completed, so click on OK, and now we want to check our result. So right click on result and click on edit. Click on insert, click on location and click on plane. Click on OK and click on apply. Okay, here our plane, and we want to check the velocity distribution inside in this plane. So select on color, click on variable. So it is our pressure. Okay, now select the velocity. It is our velocity distribution, and finally we have a temperature distribution. So click on apply. It is our temperature distribution.